Hey everyone, good evening, good morning, happy Saturday. Hope you all are doing great. With the interest of time, we'll get started. Hey Sanjay,
Sure. Good evening.
good evening.
Yeah.
Yeah, let's get started with our agenda for today. So we are going to talk about two different things today. One is about the databases, data warehouses, data lake, and data lake houses, what they are, what is the difference, which is preferred in the industry, at which point of time, how can you decide between whether you need a warehouse or a data lake or lake house, all of that. That is one aspect of this discussion today. The second aspect is we are going to talk about the ER data modeling. So in general, we have various different techniques of data modeling in the industry. When you look at OLTP databases, generally ER models are going to come into picture. And when you look at OLAP systems, whereas analytical systems, I mean, in that scenarios, you will prefer dimensional data modeling. Okay, so that is the industry-wide standard approach. So today we'll focus on the OLTP, ER diagram data modeling. Tomorrow, in our next class, we will talk about dimensional data modeling at stretch because that is a big topic. I don't want to combine it with any other topics. So tomorrow we'll do it at stretch. We will also talk about some of the SCD types and how we can implement that. Okay, so that's pretty much the agenda for this week. Let me share my screen. Okay. So, my style of explaining the concept is first I'll get started with Excel, then I'll have some graphs and I'll have some PPTs with me, PDFs with me. I'll walk you through all of that, but generally I'll start doing explaining things myself using Excel. Okay. So generally, guys, in general, there are four topics that we want to talk today, right? That is data warehouse, data lake, and data lakehouse. Okay, so these are the four topics that we want to discuss today. Is there anyone from the audience who understands any one of these or maybe multiple topics from these? Can someone give me a one line answer as to what database means, what data warehouse means, or if you know any one of these, could you please help me? Just a one line answer could be sufficient.
Storing of data.
Is it for database?
Yes.
Okay. And any answer for these three? Because they also store the data. So I want to know, is there any other answer?
Uh,
This
collection
Mhm.
collection of structured and unstructured data.
Is it for warehouse?
Yeah.
Okay, let me write it down. Collection of structured, unstructured. I'm sorry, what was the other one?
Semi-structured.
Okay.
And
Semi.
centralized repository.
Okay, is it for
Yeah.
warehouse or okay? It's a centralized repo. Okay, what else? Can anyone attempt data lake? Data lake house we can skip. I'll explain, but I believe some of you might be aware of data lake as well.
Raw
Data
unstructured
lake.
data.
Mm-hmm. Go on.
Uh, it
Raw
it be
unstructured data.
Raw, unstructured or structured?
Unstructured. Raw data
Okay.
full.
Unstructured data. Okay, that's a good point. Any last answer? I'll wait for one more answer. on these three?
Uh,
Any, you can attempt on all these three or any one. That's fine.
Data lake, it belongs to a particular data.
Where belongs to a particular data. Okay, no problem. So you all are partially correct. Okay. So database is generally preferred for OLTP systems. I'll talk about what OLTP systems are. Data warehouse is going to be prepared for OLAP systems. Okay. Data lake is purely for file-based systems. Okay. The repository for file-based systems, we'll talk about what it is. Lakehouse is a combination of data warehouse and data lake. Okay, let's just think about data lake house as a combination of data warehouse and data lake for now. This is the definition. We will go deep into this a little bit later. Okay, so this is the general explanation of what a database and data warehouse and data lake is. Let's talk about some of the features. Okay, now what is OLTP system? Okay, so let's talk about our favorite, one of our favorites, Amazon, right? So in Amazon, what happens as a user when we log into Amazon, right? We explore the items first. So uh, there must be some place where the product information is stored, correct? When we open Amazon, already there will be some products that are available. So there has to be some repository where this has to be stored. Similarly, when you search for that product, when that product is visible, the next option that you have is add to cart, add to wish list, or buy now, right? So in all these three options, what happens is add to wish list or add to cart are going to store that information in some place, in some repo, correct? Uh, Cart or wish list. In either of these cases, it has to be storing that product information in your account somewhere. Then when you click on buy now, then there will be some options like you need to make a payment, right? You need to make a payment, or you can go for EMI options or something, pay on delivery, but there will be some options related to payment, right? Again, this information has to be stored in somewhere. Let's just consider all of these are repositories, but they all of this information has to be stored somewhere to process your transaction, to place an order. Just to place an order, a system has to go through these many things from different places. Okay, otherwise you cannot buy a product through Amazon, correct? So if you relate this entire example with these concepts, a database is going to come into picture here. Okay, so product information is going to be your database. Similarly, all these three are going to be your databases. So what happens is database is going to store your current information or most recent information. That is the characteristic of database. It cannot store anything that is happening in the past. Okay, so let's say you want to view order history. Let's say you are using Amazon since an year, from an year. Okay, so let's say you want to view the order history of how many orders you have placed and all of that. So what happens is all of this historical information is not maintained in the database, guys. Only current information. What are the current products? What are the current cart items, wish list items? Okay. And what are the payment options that you are choosing for an order? Only those information will be immediately written to the database. And database is optimized for inserts, updates, deletes. Okay. If you generally understand SQL terms, there we have DDL commands in SQL database, DBMS, right? So here we have DDL, DML, right? DCL, sometimes DQL, not DCL, sorry. Right? So insert, update, delete are part of DML. right? So whenever you want to write something to a database or read something to a database, um, or update something in the database, you are going to use these three commands. So what happens is, as soon as a user want to buy a product, till he reach to place an order, right? There are going to be inserts, updates, and deletes at the backend. Okay, let's say you have removed some item from the cart or wish list. Again, there is a delete transaction. Similarly, if you are adding something, it is an insert transaction, right? So databases are generally optimized for faster inserts, updates, and deletes only. You cannot use it, or it is not well optimized or suitable for large data slash big data. Okay, the system will crash because it is heavily write heavy. Okay, we call it as write heavy. What is the meaning of write heavy? Means multiple transactions are written to this database. Okay, it is not optimized or it is not ready for read transactions. Let's say somebody wants to read their details in Amazon, in their account, about their account, like when did they join Amazon account, when did they create the account, how many orders they have placed, last year what happened, this year what happened. If you want to go through that information, right? Database is not optimized for all of those reads. It is completely optimized for writing. Okay, so immediately it will write. That's why it is write heavy. Okay, now coming to the type of data, it will only store structured data, guys. What is structured data? Any data that can be presented in terms of tables. What is table? Anything that can be presented in terms of rows and columns. Like in the Excel right now, you are seeing, right? If whenever I try to store a data in this Excel, that will be stored in rows and columns, correct? So if you want, whenever you want to talk about structured data, it will always be in the tables only. Okay, so database supports storing structured data, which can be presented in rows or columns. Okay, so it will not support any semi-structured or unstructured data. Okay, though there are some scenarios where a JSON data will be accepted, but that is a special case. But in general, most of the scenarios you are going with structured data only. Okay, so there is something called schema on write. Okay, this is the design mechanism of this database. Okay, let me write it here. Design mechanism. Okay, what do I mean by design mechanism? Every product that you are seeing here, right? Whatever we have highlighted here, all of this have their own design mechanism. That means whenever you want to use those database, you have to go with schema on write only. That's how it is designed. What do I mean by schema on write? What is schema? Okay, what is schema? Let's talk about schema. So let's say I have this information with me. Let's say I'm talking about customer table. I have customer name, okay, customer age, and customer, let's say, address or maybe phone number. Okay, so in the customer name, let's say it is ABCD, age is 1234, phone number is something like this. Okay, whatever. Now schema means you are seeing the header, right? The column names, all these three are known as schema. Okay, schema is nothing but the column names as well as their data types. For now, the data type is string or characters, right? This is storing numbers. I'm not giving you the actual values. Okay, these are just for an example. Now, customer phone number again is a number, right? So schema is nothing but what is the column name and what type of data it is storing. This is storing characters, string. This is storing numbers. This is storing phone number. This is nothing but schema. Schema on write means whenever you are trying to create a table in the database, you have to mention the schema at that point itself. Okay. So let me repeat this, guys. Whenever you are trying to create a table, right? Let's say you want to create a table called products that contains product ID, product name, let's say. So at that time itself, you have to provide the schema. Otherwise, you cannot create a table. That is the meaning of schema on write. Okay. So this is the design mechanism of the database. And most of the times, like I said, it is optimized for writes. Okay. Write heavy. It is not read heavy, which is why we have data warehouse. Okay. Now, what is OLTP systems? These are all OLTP systems. Okay. That get frequently updated on a regular basis, on a daily basis, or even on a every minute basis. Okay. In every minute, the data is written. Okay. These are for transaction based. Let's say in your bank account, you have some databases wherein it supports debit and credit transactions. Okay, every debit is going to be written, every credit is going to be written. It doesn't care about what it is writing, what data it is writing. It doesn't matter. It doesn't matter to this database what data we are writing. It doesn't analyze. Okay, if it is correct data, wrong data, bad data, good data, it doesn't care. It will write whatever you are attempting to write. That's it. It doesn't care about how that data looks. Can I analyze it future? Okay, it doesn't bother. Okay, that is the default mechanism of database, guys. Any question so far? Okay, I'll take it as a no.
Uh,
But you can
sorry.
again. Uh-huh.
Uh, you are saying data schema on right? Schema, right?
Yes. Yes.
So schema on right. If generally we create any database, generally we create a one schema, right? So in schema on write, and what is the difference between schema on read as well, right? Or can we use the schema on write use for the read as well? Because you are saying schema on write, any specific kind of the activity we perform the schema on write, and how to create the schema on write.
Okay.
And
So
why only for the schema on write? Why we cannot create normal schema in database?
okay. So there are two different terms. I mean, schema exists in data
Uh,
base when you are talking about some of the SQL flavors. Like if you go to
yes,
SQL
normal SQL.
Server, there you
Yes,
will
yes.
see some schema called DBO dot.
Hmm.
This is
Right,
the
right.
default one.
Hmm.
Okay. So that schema is different. That schema is categorizing.
Hmm.
Let's say you have HR or maybe in Amazon itself, whatever example we are taking. Let's say you have a products, a payments, okay, a payments, or maybe some logistics. These are some of the departments in Amazon. So what you will do, you will create a schema for product like prod, payment for payment, and logistics for logistics or ops, something like that.
Ah,
Within
right.
this schema, you are going to categorize your tables that are related to
Hmm.
product.
Yeah,
Correct?
that is the normal schema. Yeah, this is
This
a
is
normal
normal
being.
schema.
Yes, yes.
Whatever schema I have mentioned here, schema on
Uh-huh.
right. This is
Uh-huh.
within the table, you have column names.
But
Okay,
column name.
within each table, you have column
Uh,
name along with the column data type.
but in normal schema, like I've created a schema HR, right? In HR schema, we have to create a one table like employee. If employee have the five column, that is also we can write the schema on the five record as well. I mean five column, and we just normally insert the data in, right, in employee table. So
Okay,
just I wanted to know what is the difference of the normal schema and schema on right.
yeah, that's what I'm trying to say. If you see, I'll ask you a quick question in
Uh-huh.
the interest of time. Generally, we write command like this, right? Create table, table name.
Correct, correct.
If I execute this line, will I be able to create a table?
You are saying create table, table name. No, you have to first create
That's
the
it.
schema. Yeah,
That's
first you
it.
create the schema, then you have to create the table.
Okay, I have created a schema called HR. Within that HR, I am trying to create a table called HR dot something ABCD.
Yes, you can
Can I
create.
execute these two lines?
Yes, yes, you can execute two lines.
Oh, is it in a database?
No, no, no. You first create the schema like HR.
Mm-hmm.
Now
Mm-hmm.
you have to create the table, but create the table you have to write the some. I mean, column.
Yeah, yeah. So that is the meaning of schema on write. Without defining what columns you are going to have in the table, you cannot create a table.
Uh-huh.
Okay. So that is
Uh-huh.
schema on write.
Okay.
Okay.
Schema
So
on
I
that. Okay.
cannot create a table and I cannot, you know, without providing the column names. Like I told you, right? Column names
Uh-huh.
has to be provided. This is the
Uh-huh.
schema. The schema that you are talking about is just a categorization. It's a virtual thing. It is not
Uh,
physical.
no, no, it is a virtual things.
Yeah. So this
It's a
is physical.
segregation of the. Yeah. But
Okay. So
suppose.
without mentioning the column names and their data types, which is called as schema, you cannot write anything into a database table.
Uh-huh.
Okay.
Uh-huh.
Okay. Any other questions, guys? Okay, I'll take it as a no. So if you look at data warehouse, right? In the data warehouse, we call it as OLAP systems. Now, whatever data we are trying to write in a database, right? That data is being written without looking at the data itself. Like we are not looking at the data, whatever we are writing. But what if we want to analyze what have we done in the Amazon since an year? Let's say you have done so many orders in a year and let's say tomorrow somebody wants to analyze within the Amazon. Let's say there are stakeholders who wants to analyze what is our most top selling product, right? Or what is our sales revenue for last 1 year or last 1 quarter. Okay. Kind of. Let's say there are stakeholders, business people who want to understand the how we are performing in the Amazon. That accordingly they are going to take some decisions. Let's say the top selling product is some ABC like novels or maybe some grooming essentials. Then they will focus more on the grooming essentials. They will provide more discounts. Okay. Let's say their sales revenue is not great last quarter, but it is great in the last to last quarter. Then they are going to focus on how they can improve sales revenue, right? So similarly, they will have some questions that needs to be answered. However, the data that you are storing in database is not looking at data, right? It is just writing it. It doesn't bother about what data it is writing. And it cannot be helpful for you to analyze because the database is not optimized. So that is where the warehouse is going to come into picture. Like I said, it is OLAP system. That means it is analytical. Okay. Online analytical processing system. That means this is specifically used to store historical data that is cleaned, transformed, and business ready. Business ready means it is ready to answer your questions. Okay, so this is where the data is being analyzed. How you are going to fetch the data to OLAP systems? We are going to extract the data from OLTP systems. In this case, these three databases, and we will clean the data based on the questions asked, and we are going to prepare a OLAP system by ourselves. Okay, so that's why this is going to carry all the historical data, like since 1 year, what happened. Okay. Now this is optimized for select queries. In the DML, we have four, three are placed here, one is placed here. Because we are only analyzing, we are not writing anything. We are reading whatever we have in the database and we are trying to analyze. Okay. So this is optimized for large or complex data, but this is expensive. Okay. This is super expensive. If you are storing data in a data warehouse and that is like huge, it is expensive. Okay. And this is read heavy. Okay. Type of data is structured. Okay. Again, you cannot store unstructured data here. This is schema on write. Why? Because this is reading data from database only. So you need to have schema before you read the data, right? Tables are created in OLTP system. So obviously this is schema on write only. Okay. It will analyze the data. It will look at what, how, why, all of those questions. Okay, so that is the characteristic of data warehouse. If we go to data lake, we have structured data. We always have structured data. We are talking about structured data. What if there is unstructured data? Okay, now let's go back to our Amazon example. Let's say you have clicked on a product, let's say clicked on a laptop. Now what happens in Amazon is an entry is created on your transaction, on your event. This is an event, right? This is an event. You have clicked on a laptop and you are exploring laptops. So you have clicked on multiple laptops, but you have never bought them. You just explode. Now that becomes an event. When you buy it, it becomes a transaction. When you are exploring, that becomes an event. Now these events will be stored in some unstructured files. Okay, like text files or log files, right? Because this is really not a transaction. So why will I waste my database, or why will I write it into a database? It will throw some cost. If I write it in log files, it is cheap, right? So that's why what I will do whenever you are clicking on a product, an event is triggered and that event will be captured in a text file or log file. Now, where do I store these files? Within Amazon. I need some repository. I need some a place to store, right? And also, this is a file. This is not structured. This could have data in any format. Some events will have small information. Some events will capture more columns. We don't know how they will be captured, right? So for those purposes, we create data lake. Okay. So this is for not cleaned actually, structured, semi-structured, unstructured, all three. It will accept all three. Okay, there is no constraint that you can only store structured or unstructured data. Preferably, we use it for unstructured, but it can store anything. And this is cheap, guys. This is cheaper. Okay, the reason why it is cheaper is it is going to store raw data. Okay, what is raw data? This is cleaned data. Okay. Now, in database, you don't bother. So in warehouse, it is clean data. That means you are going to do ETL and then only you are going to bring the data to warehouse. Like we discussed, right? Based on the questions asked, you will clean the data in database and you will bring it to data warehouse. Here in the data lake, what you will do is you will do ELT. Okay, here it is ETL. ELT means first you gather the data wherever it is, and then you directly load it to a data lake. You will not process it. You will just load and keep the data here. Okay, what you will do is when you keep the data here, whenever you want to process that data, then only you will read the data from that data lake. Okay, so it's like I have mentioned in one of the posts, right, in our WhatsApp group also. So let's say you went to a market, a DMart or any supermarket. You bought vegetables. You came home and you have started using those vegetables as and when needed. You will not chop all the vegetables on single day, right? You will bring some carrot, beetroot and all. Whenever you want to make a curry, then you will chop the vegetables. You will store the vegetables for a week or for a month or whatever duration. So that is the concept of ELT. That is the concept where data lake will be preferred. Because data lake is cheaper, it can store data for longer duration. So you will chop the vegetables only when you need it. Okay. Data warehouse is not like that. Data warehouse is like ETL. You will chop the vegetables in the market itself. Of course, this is a very bad example, but to analyze or to relate both, this is the way. You will chop the vegetables, whatever curry you want to make now, you are going to chop only those vegetables. Let's say you want to make a carrot curry, you are going to chop carrots there in the market, buy it, come home, prepare the curry. That's it. You will not buy any other vegetables. You will buy only what you need. Okay. So that is the difference between data lake and data warehouse. Okay. In the data lake, as there is no processing, so you need not worry about um, what queries you are going to write and all. Processing happens outside data lake. Data lake is only going to store the data. Okay, this is perfectly optimized. I would say perfectly suited for large data. Okay, for big data. And this is neither read heavy nor write heavy because this is not going to do anything with the data. Okay, it's neither. Type of data I have already mentioned, it will store all three types. Schema on write. Okay, this is schema on read. Okay, and this is going to store the data. That's it. You are not going to do much. Okay, let me move this a bit further, guys. Okay, so what do I mean by schema on read? Right? Schema on read means because you are directly storing the file here, it doesn't matter whether it has schema or not. Right? You are not analyzing, you are not opening that file. You will open that file when you need it. So we are not creating any tables. We are not creating any, we are not writing any data. We are just storing the data. To store the data, you need not know what schema it has, what tables, what columns, what rows. You need not know any of that information, right? So if there is a log file, if there is a CSV file, if there is a JSON file, I'll just upload and keep it in my data lake. Okay. When I want to process it, then I will take care of what schema it has. That means when I am reading that file, then only I am worried about the schema. Otherwise, it can have schema, it may not have schema. That's fine. Got it? So that's about the data warehouse. Any questions so far?
So when you say we store the data, it means that we're storing it in files, right?
Yes, it
We
is
store
in
the
files.
files basically.
My bad. Yeah, it's in files. And most probably it will be in files only because for tables we have other options here, right? But I'll talk about that's a very good question. I'll talk about how files can be converted into tables in few minutes, but you are right. It is in files.
Okay.
What other questions we have?
So how to read that this file-based system? I mean,
Yes.
mm,
Generally, we use programming languages like Python.
mm,
In Python, we have
Python.
pandas. And
Mm,
if you want to dive deeper, you have PySpark, specifically for reading such files, large files, right? Um, Other than these two, you have, I mean, Polars. There are other libraries in Python itself. I think those will be enough to go through this, but there is also something called DuckDB. That's kind of a database, but that also offers you reading CSV files and some of the files. I haven't explored DuckDB a lot, but that is also an option. So programming languages are going to be helpful in processing these files, reading these files, and writing back the data to some other format. Okay.
got it.
What other questions we have? Okay. We'll move to data lakehouse, guys. So data lakehouse is invented by Databricks. That is a software, and that is their proprietary service, which they have launched long back. So what they have said is there are um, there is a debate between data warehouse and data lake, and few have preferred data lake, few have preferred data warehouse, few are using both, right? So what happened is data is siloed. Siloed means data is stored in different places. Like they create warehouse and they store some of the data. They create data lake and store some of the data. When they want to integrate these two, when a file is dependent on data that is in table, right? Think of it this way. Let's say there is a file that is dependent on some data in the data warehouse. You have to join or you have to do some transaction or operation between these two, a warehouse and a data lake. It will be really difficult for them to go with this approach. So what they have done is they have created a data lake house That is a combination of data warehouse and data lake. Okay. So what they have said is in the background, right? In the background, it will be data lake. So files are going to be stored here. Okay. So in the background, it will be a data lake. On top of data lake, we are going to give you a flexibility of writing SQL queries or using it as a data warehouse. Generally, we use data warehouse and databases for something called as ACID transactions. Okay, ACID transactions. What this ACID transaction means is any transaction that you are performing, there are four properties ACID. If you are aware of SQL, you might have gone through this topic already. ACID transaction means any transaction that you are doing will either succeed or it will fail. The complete transaction. Okay, let's say in this case, in Amazon, you are going through all of this, right? You are searching for a product, you are adding it to cart, you are clicking on buy now, you are making a payment. All of this is a transaction. Okay, when your payment fails, um, let's say some things happen here, right? So let's say you are want to order a laptop. Okay, so what you do is you click on first step is you click on buy now. Let's say you have chosen the laptop, you click on buy now, and then you choose the payment option, right? And then you place an order. If it is COD, it's fine, but assume that it is through some GPay or some PhonePay or some net banking. What happens now is these three are three different transactions that are going to hit three different places. Click on buy now is going to trigger it. Uh, it's like a database transaction. It is going to store it in a database. Payment option when you choose and when you pay. Okay, here you are also paying. You are attempting paying. So this is going to go and sit in payment database, right? This is going to sit in some inventory or something, right? That is another database. Placing an order should move this data to, it has to do two more steps. First step is reduce the stock, item stock. Let's say you are buying a laptop and there are 10 laptops in the Amazon warehouse. Warehouse means the building. So you have to reduce the item stock and then you have to mark the payment as success or mark the order as success, right? And then there is third option to inform the logistics. Inform the logistics about this order, right? There are three different options here when you place an order. So all these five things, whatever five things, either everything has to happen together or all of this has to fail, right? So if your payment fails, we don't want to reduce the item stock. Let's say I have put these three in separate transactions. If your payment fails, I don't want to reduce the item stock, right? I don't want to mark the order as success or I don't want to inform the logistics. So there is a dependency, right? There is a dependency. So this dependency can be achieved using ACID transactions. Okay, so that dependency, whatever we are trying to achieve, right, that is going to be achieved by ACID transactions. And the majority or the most important problem in the data lake is there are no ACID transactions. Okay, there is no guarantee of the data. Because there is no guarantee of the data that you are storing here or trying to process, the data lakehouse said, okay, now your preferred option is data lake, which is because it is cheap. Now, what if I give you a data lake plus the benefits of data warehouse, which is nothing but ACID transactions, or converting this or wrapping these files as a SQL layer. So what they will do is they are going to wrap this data lake files as a SQL layer where you can write queries. Okay, so under the hood, it is going to be file storage. You are going to create a layer on top, and on that layer, you are going to perform queries, and it is going to give you the benefit of ACID transactions. Okay, we will see it. But for now, the definition of data lake house is the combination of data lake and a data warehouse wherein the data is going to be stored in the data lake itself. And as an additional benefit, we are taking some benefits from the data warehouse. Okay. That's why this is also an ELT approach because under the hood, it is data lake only. Okay. So again, it is neither read heavy nor write heavy. It can store any type of data because it is data lake. It is schema on read, and it is also going to store the files and allowing you to convert the files to tables. Okay. Okay. So this is the data lake house. Cool. Let's look at this infograph. So, like I discussed, this is one of the infographs that we have. What it does is it is explaining, see, schema on write. Okay, that is what I have mentioned, and it is costly when it is when it is having more data for longer duration. Okay, then majority of the users are business analysts or data analysts who are going to consume this data, and then they are going to answer business level questions. So data lake, like it is mentioned here, majority of the data is raw. That means nobody is aware of what data it is storing. Um, Give me 1 second, guys. Yeah. So data types, like I said, we are not sure of what data it is going to have, and it is schema on read that gives you flexibility. Okay. Why? Because you are only going to look at the schema when you want to process that data. Otherwise, you don't need the schema. Okay. Majority of the times, we as a data engineer and data scientist are going to look at this data. Okay, analyst, if our end user is analyst, we are going to give the data in warehouse only. Okay, depending on the end user, we are going to store the information in lake or warehouse. Okay, like I said, this is cheaper because you are just storing the files and you are not processing it. Okay, the storage cost is always cheaper than compute cost. Whatever compute you are doing here, it is always cheaper. Okay. Now, if you look at data lakehouse, like I said, lakehouse is going to give you the benefit of data lake, but on top of that, it is going to create a layer for data warehouse wherein you can write some queries. So when you are writing those queries, right, on top of that files, then the schema is available. Okay. So there in the lakehouse, you are going to combine the users for business analyst and data scientist in the lakehouse. Okay, so there is a single platform where lakehouse, and I forgot to inform, you can build a data lake, you can build a data warehouse, but you cannot build a data lakehouse, guys. Okay, this is not a software. This is not this doesn't exist anywhere. Okay, it's a virtual thing. You will have a data lake and you will create a virtual lake house. Okay, we will see this in action. It is part of this course, it is in scope. But data lake house is something that is virtual, that is not physical, that is not present in any software or any computer. Okay, it's just a mechanism that you are following to combine the best of data lake and data warehouse. That's it. Okay. Like I said, it is hybrid approach. So schema, when you are storing the data in the files, you will consider it as data lake with schema on write. When you are creating a table on top of it, it will become schema on read. Okay. All users, because the lakehouse is created to eliminate the dependency between data lakes and data warehouse. If data lake file has to be communicated with data warehouse, it will be very difficult. So that's why The end users are all users, and cost model is also effective because under the hood it is data lake. Okay. Oh. So we will see this. This is another PDF that I have. It's a PPT. So as you can see, guys, um, this is some of the information why uh, we are going to talk about this database, data warehouse, and data lakes or data lake houses because all of the companies are data driven today. Earlier, it used to be a different scenario, but today we are always looking at data, and that's when we are trying to analyze and process the data and analyzing the revenue or decision making in the industry. Any organization you can take, all of those are dependent on data only. It could be food platforms, it could be ride sharing platforms, it could be social media platform business, or it could be some warehousing or retail e-commerce business like Amazon. All of them, all of those are having customers, and based on the customer feedback only, they are making decisions. And that feedback is converted into data. That's how they are data-driven companies, right? So the volume of data is increasing. So we have discussed few minutes ago, this is the data warehouse where it is going to store the data that is cleaned and transformed. Okay, that means the data is not raw format, it is properly cleaned and transformed. That means there is some compute power also involved. You need to write some SQL queries on some engine that will incur some cost. Okay. And this is only for structured data, guys. Okay. This will help you. The data warehouse is going to help you in preparing Power BI dashboards or Tableau dashboards. Okay, so let's say there is some there are certain questions asked by the business, like like I discussed, right? What is the top selling product? What is the sales revenue for the last quarter? How many products we have marked in discount? How many products were returned or replaced? All of this analysis questions, right? That you can answer using data in data warehouse only. Okay. We will see what the data warehouse is, how the data is stored in this data warehouse tomorrow, because the OLAP models, cubes, and we have SCD types in this data warehouse only. So we'll see it tomorrow with a project. Yeah, so it is schema on write, like we discussed, wherein a schema is applied before it is written to the storage. Okay, that gives you a flexibility of knowing what you are writing. Okay, these are some of the examples. Here, the vendors are mentioned as Amazon, Google, and Snowflake. Even in Azure, we have warehouses, but that is slowly deprecated. That's why it is not mentioned here. Okay. Yeah. So these are some of the disadvantages of data warehouse that we wanted to cover. Like there is no opportunity to store semi-structured or unstructured. That is the biggest disadvantage. And then the ETL process is time consuming. Like we discussed, the cleaning of data involves processing of data, and it is high cost because it is not optimized for storing data. Okay, it is optimized for complex queries and read heavy transactions, but it is not optimized for storage. Okay, so this is another reason why it is high cost. Okay, and please remember this word, storage and compute are tightly coupled. Okay, we'll talk about it a little later. So yeah, the next best option that people have come up with is data lake, because it can store everything and anything, because data is loaded in raw format um, without processing the data. So now you have not incurred any cost on processing. You are just paying for storage, right? That's what it is mentioned here. Decouple storage and compute. Why? Because you are not processing it, so there is no compute charge. There is only storage charge. Okay. So again, that storage is also if you look at some cloud platforms, that storage cost can also be handled because the cloud platforms gives you cheaper storage. Okay. Yeah, these are some of the advantages of data lake. Okay, so data is flexible because you store it in raw format. You don't know what data you are storing, so it is flexible to store anything, and it is schema on read. I told you, right? Because you are keeping the file, you are storing the file, you are not processing it. So you need not understand what is the schema. Okay. Cost savings, yes. Here it is mentioned for S3. We also have the same similar amounts for Azure also. If you see, it is going to be very low for storing the data. Okay, so we have saved the processing cost here. Then yeah, this data can be used by multiple teams in multiple scenarios. There is no, uh, there is no requirement that whenever you require a data, you have to do the ETL, you have to store it in data warehouse, and then only you'll be able to process. You can keep the data here in data lake and you can process it whenever you want. So it is allowing you to perform various types of analytics. And like I said, the primary users are going to be scientists and engineers because analysts are going to use data warehouse. Okay. Now, these are the problems of data lake, guys. So the first problem is it doesn't support Power BI or any sort of BI performance or BI analytics, right? Because it is structured, because it is not processed, it is just stored, right? So you cannot use it or consume it directly to prepare a Power BI dashboard or a Tableau dashboard. You cannot directly use that data in data lake to answer a business level question, right? That is the first disadvantage of storing the data. Second is lack of data reliability because it doesn't support any ACID transactions or anything that a data warehouse supports. Okay. That means there is no guarantee of the data. Okay. If two people are writing same data to a data lake, there is no guarantee that it will preserve or it will store or it will do anything. Okay. It will just store it. So there is no advantage of ACID transactions here. Then governance and security issues. The problem is known as data swamp. This could be a topic for your interviews as well. So data swamp is nothing but storing data without following any methodology. Like there will be no there will be no governance or uh, governance means there is no specific format that you have to create folders. Within the folders, you have to create subfolders. Within subfolders, you have to create dates. Within the date folders, you will upload the files like this. There will be no such governance. You will throw the files, you'll upload the files as and when you like in whatever place. It is all siloed. Siloed means um, there is no structure. There is no structure to store the data. Okay, it is randomly uploaded to any folders. There is no maintenance of this data. Okay, that is known as data swamp. Okay, so these are some of the disadvantages of data lake. Now, this is where the lake house is going to come into picture because data lake, the advantage of data lake is low cost. The advantage of data warehouse is clean data, right? So if we can combine these two, flexible storage like data lake, and then the benefit of um, clean data, we can use the lake house here. So if you see here how it evolved, now if you see what is happening is um, we are going to use some file formats, like we'll talk about it later also. What we are trying to do is we will have the data in data lake, which is in file formats. On top of that file formats, we have some programming languages like Spark. Okay, Presto is one more. What they will do is they will be able to read these file formats, right? So what we are going to do is we are going to convert these file formats into open source table formats. Okay. maybe this is too much for you at the moment, but these three, whatever you are seeing here, Delta Lake, Apache Hudi, and Apache Iceberg, what they are going to do is they are going to, let's say you have created some Parquet or CSV file. Okay, let's say employees.csv and then employees1.csv. Okay, these are some CSV files. Now, what you will do, you will upload them to a data lake. Okay, you are going to upload this file to a data lake. After that, like I said, data lakehouse is not physical, it is virtual. So what you will do is you will use a programming language called Spark in this case. And what you will do is you will try to convert these CSV files into Delta tables. Okay. So here, if you see, there is Delta, Apache Hudi, and Iceberg. Currently in the industry, only these three are supported. Okay. Either you can go with Delta tables or you can go with Iceberg tables. In AWS, Iceberg is preferred. In Azure, Delta tables is preferred or Apache Hudi tables. So what this will do is, what these three technologies will do is, they will add some additional benefits to the existing CSV files like ACID transactions. Okay, there is something called time travel. These are some of the version history. There are some additional features that you are going to
Mm.
get when you convert these files into tables. Yeah.
So this is the delta table, iceberg tables, UD tables. How, I mean, I'm not clear about this terminology. How
Uh-huh.
it is worked. You are saying the CSV file, all the CSV will read the through the Spark programming, right? And the Spark programming, which is CSV file, convert into delta table, iceberg. I mean, I'm not clear about this terminology. Can you just give me some example how this works?
Yeah, so under the hood, there is a deeper curve. There is a deeper session on this actually, how this file is converted into a table and why we want to convert this file into a table. There is a session or dedicated session to go through all of this. For now, what I want you to remember is we are not directly consuming these files. Okay, what
Mm-hmm.
we are doing
Mm-hmm.
is we are trying to wrap a SQL layer on top of this file. Okay, so
Mm-hmm.
that is
Mm-hmm.
automatically happened under the hood. Okay, so in the
Okay.
background it will be CSV file only. Okay, so let's
Mm-hmm.
say you have create. Okay, let me do one
Employee
thing.
CSV. Yeah, that is
Yeah,
already killed.
so here you have employee.csv and it is
Mm-hmm.
converted to, let's say, employee table. This is a delta
Yeah.
table.
Okay, delta table, right? Your scheme, I mean, new table, that is you're saying delta table,
Yeah,
right?
yeah, it will be a new
Okay.
table on top of this file. Okay, so
Delta
what
table or
happens?
table, I mean, sorry for interruption. Normal table or delta table is any difference?
Yes, that's a good question. I think that is easy to answer your
Yeah.
question. So normal SQL table and delta
Mm-hmm.
table. Okay,
Yeah.
so normal SQL table is physical.
Yes. That is
That
a
means
physical. Okay.
this is physical. You will write it in a database or
Yes.
data warehouse, right?
Correct.
This
Correct.
is going to
Yeah.
stored in here.
DB space.
This
Yeah.
is
It's also taking the DB space as well.
this is
Yeah.
virtual
Uh-huh.
and this is written in data lake. This is file based. Though it has a word called table, this is not a physical table. Like I said, like
Okay.
I mentioned, we are using Lakehouse. Okay, Lakehouse is virtual. You have to remember Lakehouse is virtual.
Concept.
And
Yeah. Yeah.
so anything that you are implementing in Lakehouse is virtual. Okay. So let me repeat these steps once again. We have a data lake. Within data lake, we have employees.csv. Correct? Now,
Uh-huh.
I want to apply ACID transactions on this file. Okay. Because
Uh-huh.
I don't know. This file is not guaranteed. This will not give me guaranteed benefits of ACID. So what I want to do is I want to store the file in data lake only because this is cheaper. Correct?
Mm.
I don't want to
Right.
lose that benefit, but I also want to get the advantage of data warehouse, which is ACID transactions on top of this file. So what I will do is I will create a data lake house on top of this data lake, on top of this file. So when I create the data lakehouse, this file, whatever you have, can be converted into one of these three formats to allow ACID transactions because this supports ACID transactions. To bring ACID transactions to my file, I will create a data lakehouse. And currently there are only three ways of doing this. One is either you create this CSV file into a Delta table or a Apache Iceberg table or Apache Hudi table. In our course, I am going to talk about Delta tables, not
But
these
you're
two.
saying, okay, you're saying this is the containing as a virtual thing, so right? This is a
Yes,
virtual, but virtual is doesn't exist, right? So it
yes,
should be stored somewhere in the memory,
yes,
uh, right? Nothing is
yes,
virtual, right? It's somewhere in the
yes,
memory in the system or any
yes,
specific tool, somewhere it is stored. Because although we in the SQL format, we can see the uh, DB space, we can see the schema, all those things we can physically, you can say, we can see. But
yes,
how we can say this is the delta table, you are saying this is a virtual thing, right? Virtual thing that is
yes,
somewhere it is contain the space. How we can say, how we can let you know how it is this memory, this CSV file, suppose one terabyte file, right? And how we can say delta table contain the space of the 1 terabyte. Is any specific tool or any configuration would be required? Because the virtual things, I understand the virtual thing, but how it is work for the virtual thing behind the thing, I just wanted to know.
yes. It's a very good point, but in the interest of time, and also we have a dedicated session on this, so I'll give you a quick answer.
Okay.
See, I am
Mhm.
saying this is virtual. That means it doesn't exist. But when I prepare a delta table, the data has to come into this table from some place.
Yes.
So what I will do is, whenever I want to write, let's say I want to write some select star from
Yeah, yeah. Some
employee
select stuff.
table, employee delta
Yes.
table. So whenever I execute this query, this delta table will go and talk to this file in data lake. I told you in the data lake house, the underlying storage is data lake.
Okay.
So the file is stored in data lake. Whenever you are writing queries, these queries will be executed on top of these files. Okay. Now, how this is
Yes.
happening in real time, how query is
Mm.
executed, how a query can be written on CSV file, all of that we have in scope. We have it in scope. I will also tell you why we are going with data lakehouse. Can't we write some, can't we read this or upload this file into a database or a data warehouse and write select query? We can do it, right? If we really want to write a query, we can upload the CSV file into a data warehouse directly. There is an import option. But why are we
Mm.
deciding that we need a data lakehouse? That is something that you have to learn after like few sessions. When we go
Mm-hmm.
to Databricks, then I will explain. We have a project also to build a data lakehouse. For now,
Okay.
please understand that uh, the underlying storage, physical storage is data lake. The virtual
So in
storage
like,
is
yeah,
data lakehouse.
I understand this point, but like
Mhm.
normally we execute the query, normal DBMS system perform this some query execution plan, right? Which is containing the step-by-step strategy, right? But
Yes.
how it is the is it also working the same way when you execute the query like select star from the employee delta table, right? And this employee table will interact with the employee CSV file, which contain the data lakes. Correct? So
Yes.
is any wrapper of the behind of the
Yes.
scene that is interact with the employee with the data lake? And because as per the, I mean, this is standard, right? Whenever you write any query, should be parse and execution plan, query execution plan always there, right? So if the same way it is working or any
Yes,
other,
yes. So it is going to
is
work
it?
in the same way. The wrapper that you are talking about is known as Delta
Uh,
Lake. Okay.
so we can see the
So
explain, we can see the explain plan as well.
yes, yes, you will
Explain
be
plan
able
for
to
the query
see.
as well.
Yes, you will be able to optimize
Okay.
these queries. because
Okay.
query is not executed, right? When you are optimizing the query, when you are looking at the plans, you are not actually executing those queries. So what happens is to convert data lake into data lake house, we use something called delta lake. Okay, so delta lake is the
Uh-huh.
wrapper on top of
Right.
your
Rapper.
data lake. Now this wrapper is going to allow you perform SQL queries. And this wrapper is going to bring that ACID transactions and other benefits on your data lake files.
So what my conclusion you're saying for the data lake house only you have using that is contain the ACID transactions, right? You maintain the ACID uh
Yeah, not just
maintain,
ACID, it
that
has
is
so many
only this is
benefits.
only one point. Yeah, this is only one point using the data lake house to
No,
maintaining the
no,
ACID property or
yeah. So for because the audience here understands SQL, I have mentioned only ACID transactions. Okay, there are so
yeah.
many benefits like time travel, versioning, optimizing, right? Optimizing as in optimizing these files, not tables, optimizing the files. Okay. Then there is partition pruning. We call it as partitioning pruning. Okay. Then there is liquid clustering. Okay. There are so
Hmm.
many advantages of going with this delta table. There is deletion vector. Okay. So deletion vector, all of this we have it in scope. You can go through the course curriculum also. All of these features we
Okay.
have when you create the delta table. Okay. On top of this file, you are going to get so many benefits, and we have all of this in scope. Okay. You may also ask how columns are being read because this is going to be schema on write, this is schema on read. So all of that we have a dedicated session. So it will be a 2 hour session on this entire topic. At that point of time, I'll explain the challenges
Okay.
of what happens within data lake and why we are moving to data lake house and how this delta table conversion happens. That also I'll give you a detailed overview. Okay.
Okay. So data table is the kind of the final table where we can further data scientists or
Yes.
data BI people
Yes,
can use, right? Is it?
yes. So
Or we
what?
can further it convert, no, or it can be further convert into other SQL, Oracle or Postgres or any database. Is it further
Yeah,
required or only this,
you
only this
can write.
final employee data table we can
See,
use for the further analysis?
this is the
I mean,
final
in terms
version.
of the, yeah, in terms of the reporting generation point of view.
Yeah, in terms of reporting generation, this is enough. You will give this delta tables in a model. So we are going to create some models tomorrow. In that you will be
Okay.
able to see. So we are going to prepare these tables. We are going to organize these tables in a way that it will be ready for the data analyst to consume. Okay, so this is the last step. This is the last step in the process where you will going to create the delta tables and share it with your analyst. Okay, so the analyst is going to go through those models and these tables, and they are going to prepare or answer the business questions. They can even use these tables to prepare Power BI dashboards or Tableau dashboards or anything like that, because this is going to give you a benefit of writing queries on top of files. Okay, so
And
that's uh
which tool that we are going to use to understand that data warehouse, data lake, and data lake house in software?
Yeah, so data lake, all these are in Azure only. So we are going to use Azure Data Lake Storage. This is because we are Azure, going in Azure. If you go with AWS, it is S3. Okay. There in GCS, Google Cloud, it is GCS. Data Lakehouse, it is virtual. So it is going to be Azure Databricks. Okay, here also I think you have Databricks, um, as or there is SageMaker. I think I don't remember exactly. So these are the places where you are going to prepare the Lakehouse because Lakehouse is proprietary. Okay, so this is currently offered by Databricks. AWS also created their own called SageMaker. Yeah, so this is where we are going to look at when we want to prepare the Lakehouse. Good question. Um, what else, guys? What else? We are going to continue. Otherwise, um, so yeah, the agenda or the topic here is that we have file formats, we have some compute engine. Okay. Now this files are stored in the data lake using this compute engine, using this technologies. We are going to implement a lake house and then we are going to process these files as tables. Okay. So if you see the transaction layer, that layer is nothing but the wrapper layer, like Delta Lake. I told you, right? Delta Lake, Hoodie, and Iceberg. They are going to bring you the ACID transactions and data versioning. There are some other benefits which we will talk about when we move further in the course. Okay. So that is the advantage of Lakehouse. Okay. Like you see, cost is also reduced because it is going to stored in data lake. Okay. So this also gives you a additional benefit of uh, keeping data in a single platform. Okay. So let's say you have databases, data lakes. Okay. So this is your data lake house. So in the databases, let's say you have product database, and maybe you have some 10 tables. Okay. I'm just taking customer database with some 5 tables. In data, in data lakes, you have some event files, like we discussed just above, like log files, and there are, let's say, 100. Okay. And there are some CSV files, let's say some 20. Now, when you prepare Lakehouse, right, you can convert this, you can directly store this product database 10 tables as delta tables. Okay. Products and customer. You can also store the files as delta tables, CSV files and event files or log files. Okay. Lakehouse is going to give you the benefit of both. You can directly store a SQL table as a delta table where the underlying underlying can be the product. Then in the customer also, in the data lake files, whatever you have here, CSV and event files, they will also be stored as CSV files and log files. Now, again, maybe you will ask a question that, hey, you told me delta tables, the underlying data lakehouse architecture is data lake. Now, how come I am able to store the databases tables? Because data lake stores only files, right? It only stores files. It will not store tables. Now, how come I am able to create a delta table on top of my product or on top of my database tables? So the answer is whenever you are trying to create a table, right, on top of this product, let's say there is product details. This is one of the table. So what happens is when you create this table, right, when you have this table in database, right, when you want to create it in Delta, you have to convert this product details into file based or file formats. No, file based storage. Okay. So what happens is when you want to create a delta table on top of a database table, you have to convert this table into one of the formats, one of the file formats like CSV, Parquet, or JSON, or any of the format, and that format will be stored in data lake as a physical format. On top of that, the delta table will be created. Okay. So it's not a direct database to data lakehouse communication. So the product details, whatever table you have, you will convert them into one of the file formats. And from here, you will use the same concept, whatever select star you want to write. This also gives you a benefit of unifying your data. Okay, you are creating delta tables at the end on all sorts of data that you have in your system. So this is a single place, single point of contact for your uh, different varieties of data. Correct? Even if you have data in unstructured way, structured way, semi-structured way, you can create delta tables on top of that. and you are going to use these delta tables for processing the data. So Lakehouse is going to be the single point of contact, even though you have data in databases or in data lakes, doesn't matter. Okay. Cool. All of this is going to be discussed practically in our future sessions. Do not, um, I don't want you to overwhelm you guys now. All of this is in scope of this project. We are going to convert this product details into a CSV file, Parquet file, JSON file, and we will see why we are doing it. We will use some tools called Data Factory, Azure Data Factory to do this operation. Okay, we can also do it using Spark in Databricks. Okay, we'll see both these options as to how we can do this. Maybe at that time we will gain some additional clarity because we are talking about Lakehouse. I wanted to share this point as well. So, because this is virtual and under the hood, it depends on data lake, everything has to be in file format only. Even though it is in database, you have to convert it into a file, and that file format will be converted to delta table. Okay. Now it might sound that it is additional overhead of converting this table into a file and then converting it to a table again. But when you understand the lakehouse features and delta table features, you will be able to get some clarity on why this step is needed. Okay, cool. Yeah, this is a comparison, quick comparison on what a data warehouse is, what a data lake is, what a data lake house is, like we discussed. Uh, it supports both schema on write and schema on read, like I said. It supports both ELT and ETL. The end users are all users. That is the most important thing because it unifies your storage. You can have one place where all of your data is stored. Yeah, workloads. If a delta table can be consumed by both Power BI things and machine learning as well. When we are going to use machine learning, right? This delta table data will be written into unstructured formats. Okay, that format will be consumed by RAG models. Acid transactions, yes, via layers, like we discussed. That is the primary reason why we are using Lakehouse. Cost, because low cost, because we are using data lake. Because we are using data lake, it gives you a flexibility of decoupling the storage and compute. Okay, because unless you want to use it, you will not process it. Here, you have to process it before you use it, right? Cool. Yeah, this is some of the advanced topic. Though we can discuss it later, I just wanted to put it over here to explain kind of where the industry is looking at. Currently, the Databricks is the market leader, but there is Snowflake also where they are evolving their unique warehousing architecture to a lakehouse architecture. So anybody that's not using Databricks, right? They are using the Iceberg. Okay, so if you look at AWS or Snowflake or GCP, Google Cloud or any other cloud, their primary focus is Iceberg because Delta Lake is the Databricks proprietary format. So that's why they are preparing their Apache Iceberg tables, which is open source. Okay, we'll talk about Unity catalog. For now, you can ignore. There is a dedicated session in the course. Okay. We'll also talk about Lakehouse IQ in our future sessions. Okay. So yeah, this is about why or how or when you have to choose a data lake or a data warehouse or a lakehouse, right? So these are some of your questions that you have to ask yourself or the business before you decide which one is the best choice. Okay. The basic question that you have to think about is who is consuming this data? Okay. Who are your users? Who is consuming this data? Is it business intelligence? Is it data scientist? Or is it a mix of both? Okay. And why? Okay. This is why. Why? That gives you the answer here. as to maybe they need high data accuracy and maybe they need structured data or they want to perform some ML analytics on large amounts of data, or maybe there is also a reason that they don't know what they want to do with the data. Sometimes they store it in data lake because they don't know what can come up at later point of time. They just want to store it somewhere. They don't want to lose it. So that's why they store it in data lake. So there is th- there is also a possibility where you don't have a reason to store data in data lake. Even in that scenarios, data lake is preferred because it is cheapest. If you have a very strong reason of what you want to do with the data, then data warehouse is the best choice. Like you have 100% clarity on what you want to do with the data, then warehouse is best choice. Okay. If you think today, I know I don't know what I want to do with it, but after some time, let's say you realized that okay, this is what I want to do. So in that case, you can go with data lakehouse also. So you can you will have flexibility even if your decision changes. Okay, you have the flexibility in data lakehouse. Okay. Yeah. So this is some of the information for you. Like it's important to store the data in a good format, and all of these tools or softwares that we are currently looking is because is due to maintaining the quality and correctness of the data. Okay, so the whatever we are doing, right? We are storing in warehouse or data lake or lake house. The overall expectation is the data should be clean. It should be able to explain the business purpose. It should be able to fulfill whatever we are trying, whatever it is expected from that data. Okay, so that's what it is mentioned here. Um, Yeah, this is also another important point wherein we want to build a trust with whatever data we are going to process and store. And these are some of the ways where we can maintain that communication with the data and with the stakeholders. Like you create some alerts where you are going to you are going to notify the right teams as in the teams that are consuming this data whenever there are some bad data. Okay, so we'll talk about this alert mechanism and monitor mechanism and resolve mechanism whenever once we are I think in week 6 or week 7 when we are going to actually process this data. Okay, yeah. So that's pretty much about this. Okay, so any last minute questions on the data lake house and uh, other topics before we move to conceptual or ER data modeling.
I have one question.
Uh,
Can you explain the responsibilities of a data engineer in data warehouse, in data lake and data lakehouse?
yeah,
What will be the role?
yeah, only for data engineer, right?
Yes.
Okay, so already see data warehouse is the end product. Okay, for a data engineer, data warehouse is the end product. Okay, so you will not use data warehouse in general. Otherwise, I mean, in case if the analyst or if your end users are analyst or BI team, then your end product is data warehouse. If your end user is data scientist, ML team, AI team, then your end product is data lake. Okay, when I say end product, whatever data you are going to ingest and process, it will be stored in these two places. Okay, depending on the end user. If the end user is analyst and if they are expecting some views or models for not models, views or some tables for their uh, for BI dashboards or BI analytics, you will store the data in data warehouse. If it is if it is expected to if it is expected to use this data in a model, in a RAG model, Then you are going to convert this delta table data into unstructured formats, and then you are going to give it to the intended user, whosoever it is, like scientists or ML teams or AI teams. They are going to consume that data. So
Okay.
there is no one single answer. Sometimes there is also a combination of both, wherein you have to prepare some models for this team. Models as in OLAP models, we call it as OLAP models. Here, maybe some data for unstructured way also. Okay, so that's why people are shifting towards using a single tool called Databricks or Snowflake, because they cannot adjust with these different places. Like sometimes data lake is in some place, warehouse is in some place. I have to integrate this both using some security. I have to maintain the security and policies in different places. The cost is different between both, right? All of this is a headache. That's why they are moving to a single unified platforms like Databricks, which gives you the lakehouse benefits. Okay. Yeah, good question. Okay, guys, we can get
So,
started with modeling.
sir, I
Go ahead.
have one question. So, um, in this class, it means in this training sessions, do we cover all the functionality of the Databricks?
All the
All the functionality of the Databricks?
yes. So whatever data engineer is going to do with the tool, end to end, it is covered. And see, I mean, the curriculum is in the website. You can look at it and you can even check those topics, or you can compare it with any other Databricks features. You will see 99% features on this course. Okay, I
Including,
don't want to tell you that I'll
yeah,
give you 100% Databricks experience, because Databricks is used by multiple roles. Okay,
yes,
there are analyst is going to use Databricks, scientist is going to use Databricks, AI engineers, not just data engineers, so many roles are going to use Databricks. So for a data engineer, you have everything in this course for Databricks.
okay, including
Okay.
Unity catalog, right?
Yes, yes. I mean, you can go through that the course curriculum. Let me do one
Sure,
thing. Maybe at the end of the class, I'll give you the URL in the chat.
sure.
There only it is mentioned, and whatever is mentioned in the course is promised.
Okay, sir.
Okay, there is no backing or there is no going back. It is promised and it will be delivered. Okay,
Okay, sir. Thank you, sir.
cool. Yeah, thank you. Okay, let's start with our small topic for today, which is modeling, data modeling. Okay, so data modeling is one of the fundamental step for any project, it could be analyst or an engineer, it doesn't matter. Modeling is important. Modeling is shaping your data. Okay, it's like shaping your data. You have the data, you know the data, but it's like you are shaping it in a way so it will be easy for the consumers. Okay. So what you are going to do is you are going to define some rules and responsibilities around the data before you actually gather the data. So this is of two types. Let me tell you. One is going to be at the source. One is going to be at the destination. Okay. Source means before gathering the data. This is before consuming the data. Okay, maybe these words are confusing. I couldn't get the relatable words. Before gathering data means before you actually ingest the data. Okay, before you actually bring the data, you are going to ask certain questions about how your data is going to be with the data modeling. There are data modelers, data modeling developers, or sometimes you have architects in your team. Okay, so you are going to talk about the data models with them, how your data is stored in your current system. Okay, that is what you are going to ask. That is going to come in the source. Okay, in the destination, this is to in the data warehouse. Okay, this is in the data warehouse, and this is at the before someone like analyst or some BI team before consuming the data. Then again, a model is created for them. so that their data analysis becomes faster. Okay, so this is at the read stage, this is at the write stage. Okay, no, it's reverse. This is at the write stage, this is at the read stage. This is for end users. This is for internal um optimizations or performance tuning. Um, okay, all of this. So this is the difference, guys. There are two types of models, and generally in the source, ER models are preferred. There are variety of models, okay, but ER is more preferred, and here it is dimensional modeling. Okay, we'll talk about what is dimensional modeling in our next class. In today's class, our focus will be on ER models. What ER models are, why you need ER models, and how ER models help you prepare the data and all of that. Okay, so let's get started. Yeah. Yes. Yeah. This is a beautiful way of saying why a data model is required. If you see the data here, it is present in a messy way. We don't know which table has what information, how it is related with other tables in other columns, right? We don't know what is their relationship and all. So to establish all of that relationship and all, we are going to create the models here, like you are seeing at the right side. Okay, this gives us a better view of how multiple tables communicate with each other using the columns and using the schema that is present in each table. Otherwise, it will be difficult to understand the relationship. So that's why this modeling is needed even at the source side. Okay. So traditionally, since long back, like since I think since I started my career, these are the three by default mechanisms or stages of establishing a model or creating a ER model. Okay, one is conceptual, one is logical, and one is physical. Okay, so we will do a small project on this as well towards the end, but to be clear on what this is, conceptual is only going to talk about high level information like what tables you have. That's it. What tables you have. Other than that, we are not going to discuss anything, and it is going to be like, okay, so conceptual, there is logical, and there is physical, and this is in order. Okay, first is conceptual always, logical is second always, physical is the last always. So conceptual, in the conceptual, what happens is we are going to define the tables. Okay, that's it. Like what tables we need, like maybe products, customers, orders, addresses, whatever you need, you are going to just write those names. And what we will do is we will create a box. Okay, we'll create a box. So when we move to logical model, we are going to write the column names over there. Okay, so conceptual is during our first interaction with the architects or with the stakeholders, we will just discuss as to okay, maybe we can have these tables, products, customers, orders, and addresses. Okay, this is not uh, a solution. This is just an assumption. Okay, that you can have these tables like that. Okay, let me see if I can find anything.
So which tool for the data modeling are we using? Like SQL Developer, Visio, or any other
Yeah,
tool?
so if you have multiple softwares, you have Draw.io, Lucid. There's also another one. We use Draw.io, but there is also a third one called DB diagram or something like that. But that is a bit, there is also Erwin. Erwin is licensed. I think it is
Yeah, every
proprietary.
license.
Even yeah, so Erwin is also one more beautiful tool that corporate people use to model this data. Okay, yeah. Conceptual, as you can see on the screenshot, it is like this. You just estimate what tables could be used, and like you see two boxes, right? These two boxes have purpose, which we will cover in few minutes. But like I said, this is highly abstracted. It is easily understood. It can be enhanced because the boxes you see, right? Those boxes will be elaborated and extended in our next modeling techniques. Entities means tables, guys. So only tables. You just establish a relation between tables. Okay, maybe my product table is related to sales table and sales table is related to store table like that. Okay, so this is something that you will develop in Excel only and no software tool is required. Okay, so I have it with me. Then we have, yeah, okay. So then we have logical, guys. Logical is nothing but this is your second interaction wherein you are going to decide what columns can be available based on the conversations you have with your stakeholders. Okay, so let's say they are saying that we need a tape, we need information, we need to store authentication information, payment information, like let's say orders information or addresses information. They will tell you, okay, based on that, you are going to design a blueprint. Blueprint, as in, this is just a diagrammatic way of uh, explaining the conversation that happened between you and stakeholders. It will not contain any database level uh, features in this. This is just a table name, column name, and maybe a small relation, like how they are related, like one to many or many to one and all of that. But this is just going to give you a blueprint. That means you can use this logical model and you can apply this model in a Postgres database, in a Oracle database or MySQL or MS SQL, any database. Okay, this can be applied on any databases because this is not a database specific. This is close to database specific model, but this is not the final one. This is just a logical estimation of what columns can be included and how a table can be related with other table. Okay, let's see that as well. Yep. So before, if you see, guys, here we had only tables, right? We had these two boxes. Now see what we are doing with these two boxes. We are writing something, one column at the top, and we are writing few other columns in the second box, right? Similarly, here also we are doing. Now, what this means is, uh, yeah, what this means is here you are defining the columns. Okay, now I understood tables. Now let me define the columns. What columns I need. Okay, and out of those columns, there is a concept called primary key and foreign key, and there are some other keys. If you are already aware of SQL, you might have known this. So in these logical models, right, what we do is we keep the keys columns in the upper box and non-key columns in the lower box. Okay. So what we are going to do is we are going to keep the primary key, foreign key columns. Some people also keep just primary key and foreign key columns also they'll keep in the bottom box, but it is always two box strategy. Okay. First box will have key attributes. Second box will have non-key attributes. Non-key means any column that is not a primary key or foreign key. Like unit price. Unit price is specific to products. It is not available in any other table, right? Region is specific to store. It is not present in any other table. So the columns that are unique to that table will be non-key attributes. Okay. Primary key, foreign key relationships, user-friendly attribute names. Like I said, this is still a blueprint. Okay. If you see there is space between columns and the case of the column names are also little different. They are not standard case, right? There is still much more information that we can populate here. Okay. So like I said, this is database agnostic. You can use this model and implement this in your Oracle, your MS SQL, your MySQL, Postgres, anywhere. Okay. So yeah, like we discussed, right, Erwin, or there is Power Designer, it seems. But we can also do this in draw.io or Lucid Chart. It is not mentioned here, but you can use it. Erwin is the most widely used and popular data modeling tool that is used to come up with this data modeling. Okay. Yeah, the third one is physical, guys. So physical is the actual data modeling piece that you will have to prepare at the end of the day. Let me open this. Yes. This right. If you compare this with the previous screenshot, here now we have standardized the table names, we have standardized the column names, we have also provided the column types, whether it is integer, varchar, float, date, whatever it is. Not just this, we will also include additional information, like if there is any trigger that needs to be created for this table, if there is any stored procedure that needs to be created for this table, right? If there is any index that needs to be created for this table, all of that will be included in this model, guys, final model. Okay. So that is how uh, we are going to go with physical data models. And here, if you see, the table name is known as entity. The column names are known as attributes, right? And if you see, all of these are now compatible with any flavor of the database. Okay, let's say in some of the databases, integer is not supported or float is not supported. Then this will be replaced with the database specific terms. Okay, now you will directly use this model and implement it in any model. Okay, so how do you create tables and schemas in a database? Through data modeling. Okay, so we have in the initial, in the start of this session, we have discussed, right? We cannot create a table without schema. How you are going to get this schema, guys? This is how you are going to get this schema. Okay, the schema of the table is driven by this data modeling. Okay, that's why I told you that schema is important in database, and database is schema on write. This is how you are going to gather the schema. Okay. Yeah, this is the most complex thing to build, because though it is showing only four, there will be so many other tables that are interlinked and that are related from one to many or many to one between each columns. Okay, right now you are just seeing at a table level, but this is not a complete physical data model. Okay, I'll try to gather some physical data model and share it with the group, but that is the most complex data model. Okay, so like I said, it is specific to a database. Okay, if the database supports float, integer, whatever, you are going to keep the database specific values here. And if you want to change it to a different database tomorrow, it will be really difficult because there will be hundreds of tables. Okay, yeah. So this is about the data modeling. Let's proceed. Yeah. Like I said, um, there will be boxes with the table names and there will be the relationships. Okay. In the screenshot I have shown, right? That is the standard. This is not the standard. We keep two boxes. Okay. Though it shows only single box, it will be two boxes. Yeah. These are some of the characteristics of a conceptual model. It should be easily understood, like it should have only table names, and it should not be like you are using some tools or softwares. And it should be built in a way that you can adjust it again. Like let's say after the conversation, you have felt that some of the tables needs to be added. You can still you'll still be able to do it because you have just prepared uh, a model like this. Okay, I don't want product or I don't want to time. You can immediately drop this. That's fine. So that's the concept of rapidly enhanced because it is simple. Okay. It is abstract because you are not sharing any column information or data here. You are just talking about the high level table names. This is the logical model, right? This is where you are going to apply the, see here he has mentioned the two boxes, right? So here what happens is column names are going to come into picture and the relationships will be established properly along with the highlighting the key attributes and non-key attributes. Okay. So this is how a logical model works, and this model will be used to implement, or this can be implemented in any database. Okay. Yeah, these are the characteristics. Uh, like discussed, you can apply this to any database and it is more detailed, and it will also have the clear and readable names. Though the names will not be in database specific format, it will still be a better way compared to conceptual model. Okay. And this is like we discussed, this requires some software. You cannot do it on the fly. Yeah, this is one of the example, guys. If you can see this. Uh, so if you see this, this is how the model is established here. Okay. If you all have Power BI desktop on your laptops, right? You can upload some sample files and in the backend, it will create this model for you. Okay. That way you can look at this if you want, or you can use draw.io or something for your practice. But uh, to see it visually, Power BI desktop is going to show if you upload some sample files. Okay. So yeah, this is the physical model. Okay. So here, if you see, we are specifying the actual values that will be stored, like varchar 255, varchar 100, right? Date, decimal, whatever. We are actually projecting the real scenario, which will be implemented in the SQL directly, the database directly. Yeah. You see dim and facts, right? This is also a technique that we can use other than ER modeling to prepare these physical models. Okay. So also if you see database compatible names are enforced, which we have discussed already. So every organization is going to have some nomenclature. Nomenclature means some naming convention. You have to follow that naming convention. You cannot uh, give a standard names. You have to follow that naming convention. Okay, these are the characteristic, guys. So this is database specific, and you need technical audience. That means um, not at a business level. This has to be at the associate level who understands the database terms and data warehouse terms. And it has to include everything. You cannot skip anything in a physical model. Okay, it has to be end to end. Okay, so that is the expectation from this model. Like it is mentioned, right? Indexes, triggers, and all. Difficult to change because it is database specific. You cannot change it to other databases, or you cannot even fix these things. So that's why a lot of discussion will be happening on this before you build a model. Okay. So this is side by side comparison. Um, in case if you want to uh, read, it is absolutely fine. You can grab a screenshot as well if you would like to. But like I said, physical is the last version, logical is a mid-level blueprint, conceptual is the basic level. So we are going to discuss conceptual with architects, logicals with our seniors, and then physical with the entire product team, where we are going to walk through whatever is established. Yeah. So this is the idea that gets you started. After some time, you will reach to a place where you will be able to prepare a logical model. And then towards the end, you're actually going to prepare a physical model. And this is not a one-person activity. This is a team effort. So it will not be like you are going to prepare the entire physical model by yourself or entire logical model by yourself. You will be involved in this. That's it. So this is a good to have. This is not mandatory to have. This knowledge is good to have. Okay, because there will be discussions around how you want to prepare the modeling. Okay, there will be some questions, there will be some conversations. That's why I have planned this to include this in this course. Okay, so let's check, guys. Yeah. Any questions so far?
Yes, sir. So our physical data model is tightly coupled to the type of database or not?
In physical modeling, yes, it is tightly coupled because in the industry, generally, there are certain products which will be using as a standard SQL database flavor. Like in my organization, we use Oracle for all the products. So whatever modeling we are preparing, that should be compatible with Oracle. Similarly, there will be a dialect of SQL that is preferred. That's why physical model is going to be prepared. Otherwise, logical model will work, right? But tomorrow, let's say Oracle is not um, giving us performance benefits and whatever is expected, and we want to migrate to another flavor like SQL Server. In that case, logical models will be immediately applied. We'll not start from the conceptual models, right? So that's the whole idea of going with logical and physical models separately.
Just for example, it means after creating the physical data model, we extract the SQL queries and then we apply that SQL queries on creating the database tables, right?
Yes.
Just like for example of the Irwin, if we create the physical data model, then there is some options to provide the database name like the Postgres, Oracle, SQL Server, MySQL. So in that case, we can say that is it the tightly coupled with the database or not coupled, because the tools convert the SQL queries according to the database name provided to them.
Yes. So for logical models, you can give it any name, but by the time you prepare logical models, right, you are already aware of the systems that you have with the organization. So
Yes.
you can give any name and you can prepare. But in general, the way it works is that the tools, whatever tools we are using, right, we are going to store the models based on the flavors that we have.
Okay. Yeah.
So if we are having Oracle, we are going to prepare the models on Oracle flavor. If we have it SQL Server, we will prepare it in SQL Server.
Okay. Similarly, for the database, can we also use this physical data model to the NoSQL database like the MongoDB or Cassandra?
Um, it depends because I haven't experienced it before of converting the relational data to a non-relational data. Generally, that will be a system design level concept where the databases are separated generally. So the non whatever data is not structured will sit in non-relational database. So I have never experienced a scenario where the physical models will be converted to a non-relational database schema.
Okay, okay, thanks, sir. No, sir, my question is that in the case of NoSQL database, uh, is there required to create the data model or not required?
Not required because
Not required.
non-relational generally means that we don't have the schema. It is
Okay,
schemaless.
yes.
Okay, so in the I mean in the non-relational also we have few types like columnar, graph database, and JSON based document database. So we have types. So I don't think it is going to have a schema in non-relational databases. So it is not needed.
Okay, okay, thank you, sir. Yeah. Got it.
Okay, good question. Um, any other questions? So, we have 5 minutes, guys. I don't think I'll be able to walk you through the project. I mean, I can just give you an overview. So this is the project that I have prepared for ER modeling today. So we wanted to go through this together and we wanted to build this. As you can see, projects are going to be case study based. So we are going to solve a case study in the class and we are going to discuss about some of the challenges, why we are doing this, why we are not doing that, and all of that. So this is the first project that we are going to do tomorrow. As you can see the project overview here. There is a company called Scale. It is an e-commerce platform. Though it mentions it is a competitor, it is not. So they are facing some data integrity issues and transaction bottlenecks. Their current system doesn't support the data model processing, right? So they are trying to look for a solution which can handle the complex relationship between entities, products, customers, orders, whatever. Okay, so they are looking for some OLTP modeling, wherein we are preparing some models for this company so that we actually solve their problem of establishing the complex relationship between different entities. So why are we doing this? This is mentioned here that they need a data integrity. So integrity means the relationship. You cannot have a record in orders without a customer, right? And no inventory. Inventory means stock, product stock. So stock count of stock should not be deducted if payment fails. I told you, right? If a payment fails, the number of items should not be reduced. Okay. Similarly, redundancy. You do not store so many duplicate rows. Concept of preparing this model. Concurrency. This is going to come into asset properties where multiple users can purchase at the same time. Okay. So the expected outcome, we are going to create a database schema, and these are some of the expectations. Okay. So functional requirements, these are the entities that we are going to work. And if you see, each entity is having its own concerns. For example, customer identity, if you see, there are multiple users and each user can be a buyer, can be a seller, or can be both. That means a user has to have a type, user type. That type will drive some analytics in the downstream tables. If he is a buyer, then he should be allowed with something. If he is a seller, he should be allowed with something. If he is both, then he will get the privileges of both, right? Then there is address book. Within the address book, there is a constraint that users must be able to store multiple addresses. It could be home address, work address, or anything. Okay. And that means there has to be address type, right? So similarly, we are going to see authentication is also there. That means the authentication, whatever authentication type that the user has to be stored here. Like whether it is a password based or multi-factor authentication based, along with the last login timestamp. Okay, these are all some of the requirements that we are going to translate tomorrow, and we are going to see how we can prepare a model for this. Okay, so Prime subscription means maybe they will have a membership, standard membership or Prime membership with specific start date and end date. Okay, so we will go through all of this individually and we will try to come up with a model, guys. Okay, so product catalog. Similarly, we have inventory. So we will derive all the relationships that we have here and we are going to prepare a model ourselves. I am not going to use any software because they are licensed, but I'll make sure that you all understand the real physical model, how it happens in the industry. Okay. So we are going to prepare a model. I'll look for a software. I am looking for draw.io, but otherwise we will do it in Excel also. Okay. So conceptual modeling, this is the deliverables. Okay. What you have to do. These are the requirements. This is the deliverables. So conceptual modeling, this is the requirement, and there is also a key question that we can discuss tomorrow. Logical modeling, again, there is a requirement. There are some constraints. Physical modeling, again, there are some constraints. You can, I have included this only for doing this as a minimum required thing, but we will go through all of these requirements and we will complete the modeling. Okay. So this is going to be your project, first project, and this is foundational, guys. The complexity of this project is foundational. This is not enterprise ready project. As I have discussed in some of the calls, right? There are 15 projects. Out of 15 projects, 8 to 10 project level, where the case study is more complex than you think. So there are some foundational projects just so that you understand how this works, how this concept works. That's it. This is not for some including it in resume or some LinkedIn. There are some 8 to 10 projects where it is included. Yeah, Sanjay.
Yeah, my point is we suppose that we have around 40 tables, right? 30 or around 40 tables, and we have to design the ER diagram, right? So, is there
Mm.
any quick way where we can design the ER diagram? Because if you do the draw.io or Irwin is also licensed, the company say, okay, we don't because license ER license is very ER Irwin tool is very expensive. Any other way where we can create that quickly for all the ER diagram? Because see, in generally database, if you have already database, we can quickly SQL developer or MySQL or other tool, we can easily create the ER diagram, right? No need to do nothing. We have already database. But in such a kind of this scenario, how we can quickly wrap up this ER diagram? I mean, if you have experience, I mean, that would be great.
Yeah, see, in my like you are right. In my case,
Mm,
what happens is we have something called as sprints and timelines. So
mm,
this is not a quick activity. What we do is we continuously have conversations around this, and the progress is slow, to be honest. So I am not sure about any quick way to do this irrespective of how many tables you have, there is a possibility where if the volume is really high, we are going to talk about only important database schemas. Okay. We will talk about only important things. We'll not consider everything. But I haven't experienced any quick way of doing this. In general, there is definitely a project, a timeline, a task assigned, and there are multiple people working on this. So this is fragmented across multiple people. So that is going to give some distribution, task distribution that is going to improve the overall experience of doing this. But from my experience, that is the only way where we
mm.
will do this. And one more thing, this is not uh, a regular activity. Okay, this is going to happen only when you get such projects. Okay, so
See,
there are types
basically,
of data
yeah,
engineering projects.
I understand because
Mhm.
um ER diagram generally if you have the new project come on that basis we have to design the database schema and all
Yeah.
those. So on that time it will be required. But most of the time I think schema already handy, right? Most of the time we have
Yeah.
seen.
Yeah.
Yeah, but in some time might be required in future. I'm not sure, but yeah, we should know like how the we can
Yes.
quickly draw the ER diagram because it will take time. I understand it will take because association aggregation and coupling one to many, many to one. I think that is all the business requirement you should know before draw the ER diagram. So,
Correct.
mm, okay, okay, got it.
Cool. So yeah, guys, that's all I have for today. I know it's a lot, but I also feel that we have completed some basic understanding of what a warehouse is, what a lakehouse is, and other items. So we will try to see what we can do from a dimensional data modeling perspective tomorrow. That is mandatory. Of course, this ER modeling is somewhat like it's okay, but dimensional data modeling is mandatory, and we also have to talk about SCD types. So tomorrow it's going to be fun. It's going to be interesting, and in case if you have any last minute questions, feel free to ask. And I am going to share the details of our today's conversation in the premium group that we have um, in few minutes, and then maybe you can explore. Also, I am going to give some articles related to this, so you could explore a bit more in case if you would like to. That will give you much more understanding before we meet tomorrow or maybe next week as well. Okay, so that I'm going to do it from my end. Also, there is a small assignment that I have planned for you guys, which will give you some understanding on creating models by yourself. So I'll share that on Sunday after we complete the dimensional data modeling as well. Okay, so
Okay.
if there are no more questions, we can call it off.